all meridians converge to a point at either pole. Depending on the proximity of a track to the pole and the relative angle, track direction can change quite rapidly. Sometimes it is useful for ease of navigation to follow a track that does not change direction. Constant changes in track nowadays do not pose a significant problem, as technical advances in navigation equipment can easily cope with constant track changes. A line that does have constant direction is called a Rhumb line, and this line will cut each meridian at the same angle. A Rhumb line therefore has the advantage of a constant track. From the diagram on the screen, we can see that a typical great circle track follows a different path over the Earth's surface to the Rhumb line track, between the same departure and destination positions. The disadvantage of flying a Rhumb line track is that it is not normally the shortest distance between 2 points. However, there are some special cases of Rhumb lines that do create the shortest distance, in addition to being of constant direction. For example, the equator. The track along the equator is either west or east. It is a Rhumb line as the track is constant, but it is also the shortest distance between 2 points, as it is a great circle. Another is a meridian. A meridian is both a semi-great circle and a Rhumb line. The track along a meridian is either north or south. The equator and all meridians display qualities of both great circles and Rhumb lines. They follow the shortest path along the Earth's surface, and they are also of constant direction. The Rhumb line is always nearer to the equator than its corresponding great circle path. The shape of the Rhumb line can be described as convex to the equator. Conversely, it can be described as concave to the nearer pole. In the picture on the screen, you can see that the Rhumb line direction is constant between A and B, whereas the great circle track is increasing from approximately 060 degrees to around 100 degrees. The Rhumb line track is approximately 070. In this next example, we can see the Rhumb line track from Moscow to Vancouver. It can be seen that the path of the Rhumb line almost follows a line of latitude, in a constant westerly direction. The Great Circle track, on the other hand, has a northerly track, a lot closer to the North Pole. The different paths that the Rhumb line and Great Circle follow can be seen even more drastically when portrayed on particular maps, as can be seen on the screen. Comparison of the Rhumb line and Great Circle tracks on a global scale are depicted on the screen. You can see that in the northern hemisphere, tracking easterly, that the Great Circle track starts at 030 degrees and finishes at 150 degrees. In other words, the Great Circle track is increasing. When flying in an easterly direction in the southern hemisphere, it can be seen that the Great Circle track is decreasing from 150 degrees to 030 degrees. When flying westerly, the opposite occurs. The Great Circle track is decreasing in the northern hemisphere and increasing in the southern hemisphere. An easy way to remember what happens to the Great Circle track in relation to the Rhumb line track is the mnemonic DIID. The image shows 4 segments, the north and south hemispheres, and a westerly and easterly track. For example, in the northern hemisphere on a westerly track, the Great Circle path is D for decreasing, and in the southern hemisphere in a westerly direction, the Great Circle track is I for increasing. This is a useful aid memoir and is used to solve many navigational questions. To summarize, we have seen that a great circle is a circle on the surface of the Earth whose centre and radius are the same as that of the Earth. It also prescribes the shortest distance between 2 points. Vertices are the most northern and southern positions of a great circle track. Small circles are circles on the surface of the Earth that do not have the same centre or radius as that of the Earth. A Rhumb line is a line of constant direction. It is also important to recall the aide memoir DIID to solve some navigational problems.